Good morning. Welcome to AP Computer Science A. Today we are going to go over section 10.3, binary search. So be sure to have your notes with you. Now, on your AP exam, you're going to see the binary search only on your multiple choice, which means that you don't have to code it. You just need to be able to understand, identify that that's the binary search, and understand the steps. You need to be able to understand what it will return once it finds or does not find the element that you're looking for. And to be able to help us do so, you should have your Desmos opened up and the code itself. Now, before we actually get to the binary search, do you remember that what other type of search have we done in class? So the other type of search that we've done in class is your linear search. And your linear search, what it does, it basically it just going to go through each of the elements in sequential order. Now, whenever we are getting a binary, when we doing a binary search, your array must be in order, and we are expecting it to be in order. Linear search it doesn't, but a binary search yes. Now, the following elements are in order from the smallest one to the largest, and our target is the number that we're looking for is 890. On a linear search, we start with the first element, and we're looking for 890. No, no, and we do one element at a time until we find the target that we're looking for, which is 890. So you can start to tell that this is not a very efficient way. If you know that it's in order, we probably will be jumping over ahead to have to say, well, if this is 112, this is 580, so I'll probably jump up here. But on a linear search, we are doing one element at a time without the ability to jump ahead. And until we get closer, and not yet, oh, we found it. How many comparisons do we do? We did from 0 to 18. We did 19 comparisons. What index was located? It was located at index 18. And that is what we're going to be returning. We are going to return the index where the element is found. Not the element, but the index. So let's go into a binary search. So we have the following list from 0 to 19. So we have 20 elements, and our target is 400. Now, to do so, to be able to understand that, we also need to be able to know how to trace it so we can see the code's process. So you should have a piece of paper with you. Now, let's look at the array. Your method is going to take an array of integers, the target, what we're looking for, the low, and the high. So this is slide number 2. And let's go and trace the code. So we're going to make a table. This will be your array, which is called R. Or target. Then or low and or high. Now, if we look below, notice that they give you an array of integers that is sorted. So from the smallest one to the largest one, they're going to give you the array name, which is array, the target, the low will be your 0, and your high will be the array length minus 1, which will be the last index. So in this case, it has 2, 4, 6, 8. There'll be 0, and there'll be 8 minus 1. This is index 7, and it will be received up here. Now, on your search that we're doing right now, that will be from 0 to 19. So let's write those down. The name of the array is R. Your target, we're looking for the number 400. Or low will be the first index will be 0. Or high will be the length minus 1. There are 20 elements. Minus 1 is the last index, which is 19. So therefore, once we go into our method, it's going to calculate the mid every single time. So let's go and keep track of the mid. So the mid is going to be the average of your low and your high. So low, which is 0, plus high, which is 19, divided by 2. So it'll be 19 divided by 2 will be 9.5. But because this is an integer, the decimal will get chopped off, and we're going to end up with 9. So the first element that we are going to be looking for looking at will be element 9. Is that 400? No. So it's 584. So your target is smaller than 584. So we know that your number should be on the left-hand side, correct? So therefore, we go through and say, if target is the target the one that we're looking for? No, it was not 400. It was 584. Then is your high greater than smaller than your low? No. And we're going to go through this. This is how we're going to end if the element is not found. Now, is the target smaller than the number? Yes, because the target is 400, and well, this is 584. So therefore, we're going to go into this if statement, and we're going to call our recursive binary search method, and that means that this is a recursive search, and we're going to send the array, the target, which remains the same, the low, and the high will be replaced with mid minus 1. So therefore, I'm going to take the mid, I'm going to subtract 1, and that will give me 8. So therefore, the 8 is going to replace the high. And the low will stay the same. Correct? Because now we're looking on the left-hand side, your low will be 0 and your high will be 8. And that's why we replaced we didn't replace it with the mid, because we know that on element 9, that is not going to be 400. So there's no use to be able to search for this one again. And now we're going to go through the same process. Now notice that on the left, we have 2, 4, 6, 8, 9 elements, right? So the mid will be the element in the middle, so we know it's going to be 4. But let's go and calculate. 0 plus 8 is 8, divided by 2 is 4. So that is the element that we're going to be searching for. And is that 400? No. It's 342. So once we go through here, we went through it again. And now, is the target smaller? No. Target is 400. Is the target greater? Yes. So now we're going to go through this if statement. Those two elements stay the same, the array and the target. But now we're going to replace the low with mid minus 1, and the high will stay the same. So mid minus 1, which is 3. Or so not minus 1, it's plus 1, correct? Which is 5. And that makes a bit more sense. Because now we know that it's going to be on the right hand side, so it'll be from 5 to 8. So therefore the 5 will replace your low or your high. Correct. Your 5 will replace your low. So therefore the 5 becomes your low and the high stays the same. So now we're searching from 5 to 8. Something to keep in mind that now we have 4 elements. So this is your halfway mark, correct? So which one do I need to search? The 6 or the 7? Which one do you think? Correct, the 6. If it's uneven, we're always going to search the one on the left. And if we find our mid, to be able to determine which one we are actually going to search, it's going to be 8. 5 plus 8 will be 13. Divided by 2 will be 6.5. And the 0.5 gets deprecated, so we only end up with a 6. So therefore, we are going to search the one on the left. So 415 is that it? So therefore, I know it has to be on the left. But let's go to the mid. So because we're going to the left, we're going to subtract 1, which is 5. Now the 5 is going to replace your low or your high. Your 5 will replace your high, and your low will stay the same. So now 5 equal to 5. So let's go through the algorithm before we actually open it up. We know that we're going to look at the 5, correct? So we went through here and we passed in a 5 for the low and for the high. We're going to calculate the mid, which will be 10 divided by 2, which is 5. And we're going to see, is the target equal to the element? And we open it up, and it is. And we found it. So therefore, we found it. And what are we going to return? We are going to return the index. So we are going to return the 5. Let's try one more example. Slide number 3. We're looking for the number 383 will be our target. So slide number 3. So we are going to be receiving the array name, the target. We are going to receive the low. We're going to receive the high. And we're also going to calculate the mid. So the array name will be R. That's the parameter. The target in this case is 383. Or low will be 0. Or high will be 21. Even though there are 22 elements, the high is not 22, is the length minus 1, which is 21. And now we start the process. So there are 22 elements. Halfway mark will be at the 11th element. So which one are we going to search, the 10 or the 11? We're always going to search the one on the left. Because once we can calculate the mid, it will be 0 plus 21 over 2, which is 21 divided by 2, which is 10.5. And once we search for 10.5, we know that that's an integer. So therefore, the 0.5 gets deprecated. We end up with 10. So therefore, we're going to search for the element at 10. So let's go and open it up. Too small. So now we know that's going to be on the right. So we're going to add 1 to the mid. So that gives me 11. 11 is going to replace my low. My high will stay the same. And now there are 2, 4, 6, 8, 10, 11. So we know the one in the middle will be the 6th one. So therefore, we're going to open up because now there are 2, 4, 5, 6. So we know we have to open up the 16. But let's go and calculate that. 11 plus 21 will be 32. Divided by 2 gives me the 16. So let's go and search for the 16. And it's not. So therefore, it's on the right-hand side. So we're going to add 1. And that gives me 17. 17 is going to replace your low or your high. It's going to replace your low. And the 21 stays the same. So now there are 2, 4, 5. So we know that one in the middle is the one that we'll be going to be looking for to see if that's 383. But let's go and calculate. 17 plus 21 will be 38. Divided by 2 will give me 19. And that's the one that we are searching. 373, 377, too small. So now we know it's going to be on the right. So therefore, we're going to add 1. That will give me 20. And that's going to replace my low once again. And 21 is the same. Now, there are only 2 elements. So which one am I going to open up? The 20 or the 21? Correct. The one on the left. So if it's even, you always search for the one on the left. So therefore, that'll be 41 divided by 2 will be 20.5. isn't it? So 0.5 gets deprecated. So we're going to open up and see if that's 383, and we found it. So there's going to be several questions that they might ask you. Is how many comparisons did we actually do? 1, 2, 3, 4. 1, 2, 3, 4. We found before we found it. Questions. Let's try one last one. Example number, or slide number 4. On slide number 4, let's go through the same process. We're going to write down our array. That is what they're going to give you, an array of integers, doubles, but they will always be in order. The target, the low, and the high. And we also need to be able to calculate the mid as part of the process. So let's see, our array will be R. Our target in this case will be 380. Our low will be 0. And our high, we have 18 elements. Our high will always be the length minus 1, which is 17. So we have 18 elements, which means that your midpoint is here. Which one are we going to open up, the 8 or the 9? Correct. Now, always the one to the left, which will be the 8. But if we actually calculate our mid, will be 0 plus 17 will be 17 divided by 2 will be 8.5. Integer, the 0.5 gets deprecated. So we're going to open up the 8, the one on the left of the midpoint. So it'll be 309. Too small. So now we are going to move over to the right. And we're moving to the right, so therefore we need to be able to add 1. Therefore 9. 9 will be replacing the low. The 17 will stay the same. We have 2, 4, 6, 8, 9. So we know that we need to open up the one in the middle, which will be this one here. But if we calculate, 9 plus 17 will be 26, divided by 2 gives me 13. So therefore we're going to open up the index 13, which is 343, too small. So now we know it's going to be to the right, so we are going to add 1. And if we add 1, that will give me 14. And that's going to replace the low. So therefore, the high will still be 17. We have 4, so we're going to search for the one in the middle. But there's no middle, so we're going to search for the 15 or the 16. Correct, the 15. If we add 14 plus 17 will give me 31. Divided by 2 is 15.5. The 0.5 gets deprecated, so it's 15. We are going to open up the 15 and too small. So therefore, we're going to add 1 because we know it's going to be on the right. That gives me 16. So therefore, the 16 is going to replace the low once again. And am I going to open up the 16 or the 17? Correct. I'm going to open up the 16, correct? So that gives me 33. Divided by 2 is 16.5. Therefore, the 16, we are going to search for it. And too high. So now it's too high, so I'm going to subtract 1. Now, at this point, we know visually that it's not there, correct? Because otherwise it'll be between 15 and 16, but there's no element. But your process will continue. It's going to ask you the following question. The one that you opened up was 397. Is your target smaller than the number that we opened up? So your target is going to be smaller, so we're going to go through here where we replace the high. Right? Because we are going to assume that it's going to be on the left. So we're going to subtract 1, which becomes 15. And now the 15 is going to replace which one? Your low or your high? Because we are expecting it to be on the left, it's going to replace your high. And now we're going to go through the loop. And now we're going to calculate the mid. 16 plus 15 is 31.5 divided by 2, or 31 divided by 2 is 15.5. So we're going to be searching for the 15, but we know we already searched for that, right? We know the 15 is not it. So therefore, we're going to go through the next if statement. So that's false. Is your high less than the low? Your high is smaller than your low. So that is when we end and we say it's not found. But notice that we do need to go through this step. So therefore, it's going to return -1, not found. So that is the process for a binary search. Remember that it's always going to return the integer, not the element itself. And one of the things that you have to remember is that whenever you are looking, for example, 2, 4, 6, 8, if you look on the left-hand side, we're always searching for the element on the left. So this will conclude the lesson for today. Oh, for your homework, you have to go through the next 3 slides and search for all 3. The same way that we did slide 2, 3, and 4. Take a picture of your work, submit it, and I'll see you next time.